Chapter 16, Current of Electricity, Part 4. In this last section, we will be looking at ohmic conductors and non-ohmic conductors. Okay, we need to understand that resistance of object does change with temperature as well. It does not only depend on length, resistivity, and cross-sectional area. The temperature does affect the resistance, and most of them will have higher resistance as temperature increases. That is the case for most of the metal. So you can take a look at this diagram. As the temperature increase for copper, aluminum, lead, all of them, the resistance increase because at a higher temperature, the particles inside the metal will start to vibrate about more vigorously, and this will increase the number of collisions between the free electrons and the metallic ions. So this will slow down when there's more collision. This will slow down the flow of charges and will slow down the current. Okay, the rate of flow of charges, which is current. Okay, so the amount of current for ohmic conductors, okay, or usually metals, we call it ohmic conductors because the amount of current I is directly proportionate to the potential difference V across it. So in mathematics, I is directly proportional to V. So if we plot a graph of I against V, okay, it should be a straight line and pass through the origin. Okay, so things that obeys these equations or exhibits these linear equations, we say it is an ohmic conductor. We say it is ohmic. Okay, so the voltage across a conductor is directly proportional to the current flowing through it, provided that all the physical conditions, such as temperature, remains constant. Okay, but not everything have this direct proportional relationship. Okay, some of the items do not have this directly proportional relationship. We call it non-ohmic conductors. Okay, because the resistance change as current flows through it, the temperature change, the resistance of all these things change. So there are two non-ohmic conductors that you must know. One of them is a filament lamp and one of them is your diode. So you can see this diagram in your textbook. Okay, you must know the shape, okay, of the IV graph for your filament lamp as well as your diode. Okay, so for your filament lamp, okay, the IV graph looks like this. Again, it's not a straight line. It doesn't pass through the origin, so it's not directly proportional. I is not directly proportional to V, and it's not an ohmic conductor. We call it a non-ohmic conductor. So why does filament lamp have such a graph shape? You must also be able to explain. This is because after you switch on for some time, okay, more and more current or more and more voltage flows through the filament lamp. Okay, the filament lamp gets hotter and hotter and hotter. When the filament lamp gets hotter and hotter and hotter, okay, the resistance of the filament lamp will increase. So as the resistance increases, okay, the IV graph will curve like this. So you take the voltage at this point divided by the current at this point as compared to you take the voltage at this point divided by current at this point, you get the resistance over here. Okay, as more current flows through it, is higher than the resistance at the start. So you can read the description. As electric current increase, more energy will be transferred from the chemical potential store of the battery to the internal store of the filament. Internal store means heat. Okay, this will in turn increase the resistance of the filament, which limits the rate of increase of current. Because I have more and more and more resistance, my current doesn't increase as much. So the increase in current gets lesser and lesser. So the ratio of V to I shows the increase in the filament resistance. Okay, on the other hand, a diode, okay, commonly known as the LED lights, your light emitting diode, have an opposite relationship. It looks like this. So a diode only allows current to flow in a single direction. Okay, so when you see that the voltage is in the negative section, it means current is flowing in the backwards direction. Okay, the diode do not allow current to flow in the opposite direction. So you can see that the current is almost close to zero. We say that the resistance of the diode is super high. Okay, the current cannot flow. And then at the start, Okay, we also say that the resistance of the diode is very high, so there is not much current flow through. But as more and more current flows through in the positive direction, okay, more and more current flows through, the resistance actually decreases drastically. That's why when the resistance decreases, the current increases sharply. Okay, that is why people like to use LED light rather than filament lamp, because filament, after you switch on for some time, resistance increase, then your filament lamp will need to take in more energy to stay lit. So it will actually consume more energy. But for LED light, it's very energy saving, because after switching the front part where you just switch on, you need to use quite a lot of energy because the resistance is high. But after you switch on for a period of time, the resistance is actually very small. Okay, it allows a lot of current to flow through, so you don't need so much energy from the source. So your electricity bills will also be lesser. So you can read the description. When a positive voltage is applied to the anode of a is applied to a diode, a large current will flow. We say that the resistance in this forward direction where the V is positive is very low. But in the reverse direction, okay, when a positive voltage is applied, the current is very low or almost zero. We say that the resistance is very high or almost infinite over here. Okay, that's it.